Technically speaking, technically speaking, I ain't talking vegan when I said that I've been eating, making money on the side, but I use it for the main. I'm speaking in code when I tech talk that financial freedom. Have a seat cause you gon' wanna sit up at my table, yeah. Plugged in that it, girl, IT with the cables, yeah. Network engineering is for you, it ain't no labels, yeah. Shaky with my passion, took a leap, it got me stable, yeah. Now I make 100K or better, paper couldn't fit a stapler, and I spend it on my passion cause I'm capable. Technically speaking, now I'm really talking vegan when I said that I've been eating, I've been technically speaking. Technically speaking, China white. When I've been said I've been technically speaking. Said I've been technically speaking. China white.
Your career. Now, today we're going to be talking about IPv6. Now, we talked about IPv4 addresses, and today is IPv6 addresses. This is lesson 1.8 and 1.9. We are still in first section, network fundamentals. We're coming to the end of that. Today is Friday, so we will have class Saturday and Sunday because there's no days off. We need to get to where we want to get to in life. And until we get there, we have no days off, right? Because we have not accomplished our goal. But we must continue to keep our foot on this gas. All right. So let's go in to IPv6. All right. IPv6. Now, we talked about what IP means, right? IP stands for Internet Protocol. The V stands for version. And the number 6 stands for the 6th version. Can you mute, please? Thank you. 6 stands for the 6th version. So yesterday we talked about the 4th version. This is the upgraded 6th version. This is now the current version of the Internet Protocol addresses. Why don't they have a version 5? Why did they just went from 4 to 6? I don't know. Ask them, right? But we know that IPv6 is the latest. All right. So IPv6, 6th version, the characteristics of IPv6 is it's 128 bits, right? 128 ones and zeros. We talked about bits yesterday. An IPv4 address is 32 bits in total. But this IPv6 is 128 bits total, all right? 128 ones and zeros. That's a lot, okay? And since it's so many ones and zeros, when it's not just in numbers, we also have it for us to read outside of computer language, but for us, we understand it in hexadecimal, right? Hexadecimal means that the numbers go from 0 to 9, and then from A to F, I believe. So 0, 1, 2, 3, 4, 5, 6, 7, 8. Oh yeah, here it is. 0 to 9. And then after 9, because there's no 2-digit numbers, after 9, you have A, which equals 10. The letter A for alpha equals 10. The letter B equals 11. The letter C equals 12. Okay, you catch my drift? So it's just going to keep going until you get to the letter F. That stops it, okay? So that's what hexadecimal is. You may hear hexadecimal outside of, this lesson, outside of network engineering or tech, right? You may see hexadecimal other places as you are living your life. And now you can understand what hexadecimal is. It is basically letters and numbers grouped together to make something, okay? Now, with IPv6 address, they look something like this, right? Or you can see it in this picture, this diagram right here. It's very long, as you can see. It is extremely long. And it's easier to say, oh, what's your IPv4 address? Oh, it's 192.2.1.6. That's pretty easy. But imagine calling support or being support, and you're like, I need your IPv6 address, okay? Imagine reading that out. 2001:0:9D3A, and then you got DBC, like, is it D as in David, B as in boy? Like, that is a lot, right? So IPv6 is crazy long and it looks very complicated, but they are very, very unique. Now, before we get into the uniqueness of it, in this diagram, as you can see, it says the zeros are shortened to 10. Now, with these IPv6 addresses, you may see that there is a consecutive line of zeros somewhere. And most of the time, they shorten these to make it to make the address a little bit shorter instead of this long run on. So if it's 4 consecutive zeros, then they will shorten it to have 10. So if you see 10, that means that there's 4 leading zeros or 3 more leading zeros, however you want to put it. In this area, it is 4 zeros. Okay. So going down some more. Now, we talked about subnetting, breaking addresses down because, we don't have enough addresses, and private IP addresses because we don't have enough IP addresses. But with IPv6, that is not the case. We have an address for a unique address for every single device. How, Sway? Okay, so I'm going to skip a little bit of this really quick, just so we can talk about that. So IPv6 address is made, was created based off your MAC address, okay? So that's why it's so unique to each device, because it's the IP address and the MAC address came together and had a baby. That's basically what an IPv6 is. So it's very unique, no need to subnet, no need to break things down. It is as simple as what it is. Now, it's good to understand how IPv6 addresses are made and created. This is something you will not have to do. The computer does this automatically. You just need to understand it, okay? So it takes a MAC address and it separates the address and puts the MAC address right in the middle, okay? Now let's go up a little bit. Now, what is it separating? It has, as we talked about in V4, a network part of the address and the host part of the address. IPv6 has the same thing. They have the first 64 bits is the network part. The last 64 bits is the host part. Okay, it's where your MAC address will come in. The MAC address is what, 32 bits? MAC address is 48 bits right here. The MAC address is 48 bits. So this node, aka host, is 64. So that means we need more digits. If a MAC is only 48 bits, we need more digits to make 64 bits. How do they do that? They literally shove some, they shove this, let me see. Is it just this one, FFFE? Yeah, they see it right here. They shove these letters into the middle of the MAC address so it can be a fully 64-bit EU 64-bit MAC IP address. Okay, so IPv6 is a address that is 128 bits long. Okay, the first 64 bits is the network that tells as you're sending data, it says this what network you belong on. You belong on this home network. You belong on this work network, on this school network, on this Houston network. Okay, you catch where I'm going? And then the last 64 bits is all about you as a unique identifier, your host, your computer, right? And each computer has a specific or unique IP address. How do you get that unique IP address? They shove this FF right here. They shove this FFFE right in the middle of the MAC address and say, boom, that's the last part of your IPv6. Again, this is automatically done by the computer. You don't do it. You just need to know how it gets done, okay? And it's done by this keyword, extended unique identifier. So anytime you see an EUI 64 format, that just means that the 64 bits for the host address, for the host part of an IP address, is the MAC address with these FFFE just pushed in the middle. Okay.
In today's fast-paced world of technology, staying ahead of the curve is essential for success. But with the ever-expanding landscape of IT certifications, mastering the right skills can seem like a daunting task. Introducing Tech Exam Mastery, your ultimate solution for conquering IT certification exams with confidence. Whether you're aiming to become a networking guru, a cloud computing expert, or a blockchain innovator, Tech Exam Mastery has you covered. Our meticulously curated notes provide in-depth coverage of key concepts, organized in a clear and concise format, saving you time and effort in your exam preparation. Join the thousands of IT professionals who have unlocked their full potential with Tech Exam Mastery. Accelerate your career growth, expand your skill set, and boost your earning potential. Don't just adapt to change, lead it. Tech Exam Mastery. Comprehensive prep notes for IT professionals. Click the link below to learn more.
As you can see here. Now, in this diagram, it's showing that the end of the MAC address is the NIC, right? The network interface connection. And that's, like I said, usually for the manufacturer comes up with the MAC address and make sure that this is unique to each device, because that's how they manufacture it. They want to keep track of all the devices that they have created, right? That's usually a MAC address. We'll actually get a little more into MAC addressing because we have to deal with talking about network access and switches. And switches only read MAC addresses. So we'll go really deep into it. So we're not going to go too deep right now with MAC addressing because I want you to fully understand IPv6 addresses, okay? This is what an IPv6 address looks like. I showed you guys yesterday on my computer what my IPv6 address looks like, all right? Okay, so let's go down some more because you don't have to subnet. You don't have to know how to, we don't have to, break any of these IPs down. You just need to know how do we come up with this IPv6? That's it. So you may get some type of question is how is an IPv6 address made, right? This is what you want to be talking about or looking for because it's multiple choice. Extended Unique Identifier, or for short, EUI 64 format. Anytime you see EUI 64 format, it deals with IPv6 addresses. And what does that mean? That means that the MAC address is separated, split in half, and this FFFE gets pushed right in the middle. And you will have a question like that on the exam, I kid you not. And they will say, what's in the middle of the MAC address to make to complete the EUI 64 format? And they'll have FFEF, FFCF, FF, right? Or FFFE. So it's important to understand what gets pushed in the middle to make this EU64 format for an IPv6. That will be a question. Trust me. I've studied this a lot, so I was able to, once I saw it, I automatically knew like, oh, it's FFFE, okay? All right, moving on, okay? Now, they kind of give you a little bit more, at least in this blog, on how it actually changes the full thing, because you push it in the middle, then you probably change the first 2 bits. We're not going to talk about that. You can read more so you can have more knowledge on it, but you probably wouldn't run into that most likely on the exam. This is more informational, okay? Another thing I want to point out is informational. It's good to know, period, is the RFC, right? So we have a lot of rules and regulations, and they're usually in the form of what's called an RFC, okay? So RFCs, for this one, the reason for why we're converting these MACs into IPs can be found in RFC 4291. I think it stands for request for comments. That's what the RFC stands for, I believe. I don't know. You can Google it, check me. But I'm pretty sure it's a request for comments. And it's basically this technical document that outlines the reason of why they're saying you have to do something, because everything is a rule based on the IEEE people, okay? These are the people that's smarter than all of us. They're the engineering, electrical institution people, whatever. And they tell us what we can and cannot do. They tell us why things are this way, why we can't do this, why they set this out. And if you are one of those people that always wants to know, well, why? Well, why? Well, why? Well, you should, get familiar with RFCs, request for comments. If you are big in blockchain, RFC will be really good for you as well, because the blockchain, anything that's going on with like cryptography or the SHA-264 algorithm, it's all in RFCs, right? I don't know the exact RFC numbers for each one of them, but it's good to get familiar if you're one of those why people, okay? Now, again, we talked about the upper bits being for the network, the lower bits being more for the host. The host is that computer, that unique device that's trying to access the network. Now, the IPv6 sends data in different ways, just like the IPv4. It said multicast, broadcast, unicast. But for V6, there is no broadcast, okay? There is a unicast, single interface. We kind of know what unicast is, one-to-one. Anycast is sent to the nearest host, the nearest device on the network, right? So it's not broadcast. We're just going to send it on out, and it's going to go to the next device in line, all right? The nearest host on the network. And then multicast is like a group chat, right? Maybe not everybody, but maybe just the HR department, maybe just the engineering department, maybe just on the guest network. I don't know, but it's just for a group of hosts, a group of devices, a group of users that want to get this message, okay? And even says it right here, IPv6 doesn't support broadcast method. Broadcast has been replaced with Anycast and Multicast, okay? So when you think of how IPv6 sends data, this address, it sends it in a unicast, anycast, and multicast, 3 ways. Now, it gets even more complex than that, because V6 addresses have 3 types of unicast, right? So let's go into it. We have a global unicast. We have a unique local unicast, and we have a link local unicast, okay? I like this diagram right here because it kind of shows it to you visually. I like to learn stuff in a visual way. So a global address type, as you can see, it's global, it's everybody, okay? And then we got unique local, which is not everybody, but not everybody in, let's say they're in the internet, but more of a network type, more of like maybe just in a company, or maybe just in this type of network, okay? That's unique local. And then link local is more like private IP addresses. It's more like only in your network. You don't have to route to the internet. You don't need the internet. You just need to talk to everybody around you, right? So you don't need the internet to get this address and send it out. But unique local is for, you do need the internet, but just in a subset, which would be in one like company network, or maybe a school network or something in that sense. And then global is like everybody, right? The internet, you can say. So this right here kind of makes it come together. And these are the 3 types. These are the 3 types that you must understand the difference, okay? On the exam, they'll get a little technical, okay? So global unicast addresses, they start with 2001. Anytime a IPv6 address starts with 2001, global unicast, boom, that's it. Let me see, let's go up. I think we have there we go. Here's in this diagram, right? 2001, automatically global unicast. You don't care about anything else, global unicast. Going down, unique local. Unique local says that they have what's in the middle is FD or FC. FD as in dog and FC as in cat. You will see, I think it's always 00. Is it always 00? It just says FD right here, but I'm pretty sure it's always a leading 2 zeros. So FC or FD followed by 2 zeros. That's how you can tell it is unique local. Okay. And then link local is FE. FE as in Edward, and then 80. Okay. Now, how I remembered these was flashcards. Okay. I would literally put global unicast, and on the other side of the flashcard, I will put starts with 2001. For the next flashcard, I will put unique local, unicast maybe, and then flip it over, and I will put FC00, and then under that, I will put FD00, because it could be one of two. All right. And then for my other flashcard, I will put link local in the front and then flip it over and put FE80. So then when I go back to review my flashcards, I will be like, okay, global unicast. Maybe on the front, you can say global unicast starts with, right? Global unicast starts with, is it 2001? Flip it over. Did you get that right? All right. You need to keep doing that so you can have it, you can remember it and have it in your head. This is for the exam specifically. For the Net Plus, you probably it won't get this deep in Net Plus. But for CCNA, it will. And that's a good way to test yourself to keep it in your head. Unfortunately, you don't need it after that. Once you get into this real world, they don't care that you understand what that means, okay? Because it's nothing, everything is a Google tap away, right? So this is something that's specific to the exam, but the exam is basically saying, hey, this person is certified to Google, right? Basically, this person knows the foundations of networking, and if they Google something, they know how to research and find the answer, okay? But you have to pass the exam. And this is probably and they would probably break this up into like 3 or 4 questions, which is a lot, like 4 questions just on Unicast. 1 question is global, the next question is unique, the next question is local, and then the next question would be what is inserted in between the MAC addresses to make the EUI 64. That could be 7 questions right there on IPv6. So we want to get every single one of these little easy questions right, because that's an easy question. What's a hard question is subnetting questions. Find the host ID, the network ID, how many hosts per subnet. That's hard, okay? With me, I'm gonna skip those questions because I ain't got time, right? But I'm gonna get every other question right, because all of this is nothing but memory. It's a game of memory, right? And as you continue on in your career, you may see it once or twice, but the point is you got the cert to make the money, okay? To be qualified to sit in the chair to make the money, okay? So yeah, if anything, please, please, please do not skip the 3 different types of Unicast V6 addresses. That is so important, okay? Let me see, what's this? There's 4. Let's keep going up. Oh, another thing is V6 addresses, was another good reason for it, is it already comes with security, right? They have what's called IPsec. IP stands for what? Internet Protocol. Sec, right? If you're not already in tech, because they say sec a lot, SEC, sec just means security for short. So IP security. So IPv6 already has security built in. They're like, hey, we already come secure. IPv4s are not secure, okay? They're just some numbers put together. So that's another big thing, and that will probably, most likely, be a question on both the CCNA and the Net Plus. Oh, here it is. Built-in security, IPsec. They probably will ask you, what's one main difference between IPv4 and IPv6 addresses? And then in your multiple choice, they'll have, all different types of answers. But one most likely will be built-in security, built-in IPsec, something in that sort, okay? It wouldn't help, it would help to know that it's RFC 460 for IPv6. That may be like another flashcard you'll have for yourself. IPv6 is governed under the code RFC 460. I'm pretty sure that's going to be on the exam Net Plus or CCNA. And yeah, that's really about it for IPv6. Okay, the main things is that it is 128 bits, it's hexadecimal, RFC 460, built-in security IPsec. All right, hexadecimal 0 through 9, A through F. And instead of decimals, it's separated by colons, which you can kind of see already. Let's see. Split into twos, split half. First half is the network, 64 bits. The last half is the node or the host, 64 bits, right? The lower 64 bits is used for the host, and it is called the EUI 64 format. What is that format? Okay, this format is saying, hey, we're going to take the host MAC address, which is 48 bits, and make it 64 bits by adding FFFE in the middle. All right, that's the easy way I'm going to explain that. Okay, if you want in a more technical way, I'm going to give you this document so you can see the technical way. RFC 2373 allows a host to assign itself a unique 64-bit IPv6 interface identifier. This feature is a key benefit over the IPv4 as it eliminates the need of manual configuration or DHCP, as in the world of IPv4. That's the technical definition. But that probably confused you, like, what? What's going on? Listen, takes the MAC address, splits it in the middle, and adds FFFE, period. Moving along. Okay. And then we talked about the different types of how it sends data: Unicast, Anycast, and Multicast. IPv6 sends it 3 ways. And then in Unicast have 3 types. Okay? Global, unique, and link. All right. I look at global as the internet address. And then I look at link as a private IP address that doesn't need to route on the internet. So of course, by default, the other option would be unique. So that's another little tip or tactic that I would use to remember it. Global, is internet, right? It's everybody. Link, local, it says local. So it would be something that's only local in my network. It is something I would compare it to private IP4 addresses. Okay. And then of course, like I said, the middle would be the default. So if I already know the first one and the last one, I'm pretty sure the middle one will get whatever's left. All right. One thing I can say is taking these multiple choice questions is process of elimination, right? So you want to be able to eliminate what is not true quickly. Okay. So you can give yourself a best chance to get the right answer right. Because I ran out of time in my CCNA. So the test just cut off on me right in the middle of my questions, and I still passed because I got more questions right than what I got wrong. And that's because I'm not gonna take my time doing all this subnetting, right? It's good for you. You know, I'm not saying don't do subnetting or don't pay attention to the hard parts, but I'm gonna focus on my strengths and I can remember some things, right? I can do my flashcards and remember the things. And if I can't do the things that require me to use a little more logic than what I want, then I'm okay with taking a hit on that, okay? So you have to figure out what's your edge. And that was my edge, flashcards, okay? And then visuals, my big thing. I needed to see what it looks like. What does that look like? What does global would look like to unique, to local, to the link one? And this one's great. I found this on the internet. This is another blog that I came out with when I had my first contract. So as you can see, global is the big one, unique is the middle, and then link is the smallest, which would be private. There are 4 methods of assigning IPv6 addresses. Honestly, I don't want to get too into this because we're going to do this when we get to section 3, because we're going to have to start going into routers and assigning IP addresses, IPv4 and IPv6. Once we get to section 3 and maybe section 4, we're going to be configuring DHCP. So I don't want to get too technical with these things, especially if we're going to already go over it in section 3. Let's get through section 1 first. Let's understand section 2. And then section 3 will repeat. You know what I'm saying? You'll see these things again. We'll just go in deeper. All right. So if you want, you can, do some digging. But I feel like if I would have to go through this, I would probably have to explain a little more than is needed. And I don't want to take away from this lesson. This lesson is literally describe IPv6 addresses, okay? Be able to identify, and specifically identify these address types: global, unique, and link. All right? We don't want to put too much in our head at one time. We want to bite it off little pieces. But every day, that's why we're going to continue every day, 7 days a week, with learning this until we finish. Okay? All right. So next on the list is verify IP parameters for the client OS, right? Client OS is just what's on your computer, your operating system, Windows, Mac, Linux. I don't really work with Mac. I'm kind of like an Apple hater. So I'm always going to deal with Windows. And if I can't deal with Windows, I'm going to go to Linux. I will barely ever touch Mac. Mac is ill, okay? But if you have a Mac, hey, no hate, you can still verify your IP parameters. And even on a Mac, you can download the Linux software and use that as well. And you can download a Windows, We'll get, maybe not in section 1, but we'll get to a point where we will configure virtual machines, maybe in Oracle, maybe on Microsoft, maybe AWS, I don't know. But we will configure a virtual machine, turn that bad boy on, and we'll be able to, let's say you have a Mac computer and this virtual machine, we'll put a Windows software on there so you can play around with Windows. Or us, for our Windows people like myself, maybe we'll put a Mac OS onto the virtual machine and play around with the Mac operating system, and so forth and so forth. But we'll leave that for another day. For this section, they really just want you to discover these IP parameters, which is your DNS server, your default gateway, your own IP address, and your own subnet mask. Now, yesterday we did do that, but I don't mind showing you guys again. But first, let me go through in these screenshots, since I don't have all of these operating systems to show you. Now, for Windows, you can go into, they have, your network connection and your settings. It's called a GUI, G-U-I, a graphical user interface is what that stands for. Graphical user interface is something like this. You go into the settings, you click on your network, click on Wi-Fi or Ethernet, very nice, clickable, save, got the X and everything. But CLI, which is the command line interface, is a black screen with some white letters and you're running commands, like you're a hacker or something, like you're on the Matrix. Again, we did some of this yesterday, but I can still show you today. But these are the commands we did yesterday. ipconfig, you could do ipconfig all to see these parameters, okay? You can even do net status, right, run. For Mac, it's kind of the same, but, excuse me, you have ipconfig. There's no ipconfig all, you just got ipconfig, and you got net status or net stat. RN. It can be as well a nice graphical user interface as such in this diagram here in the screenshot, or CLI, command line. All right, when we say the command line, CMD, command prompt, that's what we have it on Windows. This is the command line, okay? This is exactly what the command line looks like. This is for Windows. I am a voice network engineer, so I will deal with voice servers. So our servers kind of look like this. One of our servers is called Call Manager, or CUCM, and it'll look something like this. And we'll sign in with our username and password, and we will run commands and debugs and figure out what's going on. Some people do not know, some engineers do not know how to use the CLI, which is crazy to me. And they love the GUI, graphical interface. So they like to click through, click save, click the back button, click the X. Really good, no hate to them. But when we as engineers use the command line, the black line, then it gives us power. They say, oh, you know a little something. I guess you are an engineer. Yes, I am. Okay. And then Linux kind of has the same thing with the configs. And these configs, IF config, hold on, IF. Yeah, I don't know why I said IP for Mac and Linux, but it's IF, F as in Frank, config. And the same with Linux, IF. This is how you are able to see these parameters, okay? DNS server, default gateway, that's your router to help you leave out your network. That's what the default gateway is. And then your own IP and your own subnet. All right, so these are literally just some screenshots because I don't have all these OSs. I just have a Windows OS.